Hello, Year 11. Here are the answers to the work I set for you online on Friday, just for you to go through the properties of hydrocarbons. So, well done to the 14 people that logged in to do this work. Okay, you were absolutely correct, all of you. The name of the process for separating crude oil is fractional distillation. Now, what property of each product in crude oil allows it to be separated? So you've got to think logically here. Crude oil is a liquid and we're heating it up. So is it going to melt or is it going to boil? So the boiling point, the point which it turns into a gas, is the property that allows it to be separated out. They turn into gases at different temperatures, which means we can then separate them out. What is meant by the term finite resource? So finite resources have only got a certain amount left. They are eventually going to run out. Crude oil is an example of something that is a finite resource. Name one condition needed for the formation of crude oil. So you could choose two actually here. You could pick high temperature or you could pick high pressure. Both of those were correct answers. Draw the structure of propane, 3 carbons. So when we're looking at these hydrocarbons, we remember that every carbon atom forms four bonds, 4 covalent bonds. So if you draw out your 3 carbons and you put 4 bonds on each of them, then you just fill up all the empty arms with hydrogen. So we've got C3H8 as the formula for propane. So we know from last lesson fractional distillation will separate them into fractions. What is the relationship between chain length and boiling point? So the chains at the top of the tower had shorter chains, but they boiled first, so they had lower boiling points. At the bottom of the tower were the longer chains, and you had to heat them more for them to boil, so longer chains have higher boiling points. Petrol and diesel are used as fuels in car engines. Why might natural gas be unsuitable for pumping into a car? Really, you could choose any of these reasons were correct. All 3 were correct. It was a trick question on my part there. Okay, natural gases produce greenhouse gases like methane, but equally petrol and diesel, when they're burned, produce carbon dioxide, which is a greenhouse gas. So that might not have been your wisest choice. Gases have a low density. The particles are far apart, so you wouldn't get as much in the tank. You wouldn't be able to get as far as you would if you used a liquid, where you've put more particles in that could then be part of a reaction. But equally, gases would float away when you try to pump them. As soon as you turn the pump on, you couldn't guarantee, once the lid was off your petrol tank, you couldn't guarantee that they would all go in there. So really, any of those answers were correct. Petrol flows easily. It has a low boiling point, so it vaporizes easily. Okay, what does vaporize mean? So it's where it evaporates. It becomes a gas. So volatility is how easily a substance evaporates. So you're asked to write this down. I really like it actually when you send me a copy of your notes to show me how hard you've been working. I do like that. So we know from last lesson the boiling point increases as the chains get longer. This means shorter chains evaporate more readily. So does a volatility increase or decrease as the chains get longer? So volatility is your ability to become a gas. Then this must decrease as the chains get longer. It is harder for the longer chains to become a gas. Okay, next slide. So volatility of fractions. Petrol flows easily, has a low boiling point, and vaporizes easily. This means it ignites easily. So petrol is higher up in the tower than diesel. Diesel is more viscous. It has a higher boiling point. It's less volatile. It ignites less easily. What does this suggest the relationship between volatility and flammability is? So you should have selected the higher the volatility, the more easily it becomes a gas, then the higher the flammability. So it's those gas particles, it's the fumes of the gas that are on fire, not the liquids themselves. Okay, so one important thing to remember is that each crude oil fraction isn't a single chemical with one chain length. They make up a range of similar chain lengths and therefore have similar properties. So they're not identical in size, they're not identical chemicals. Okay, so you were asked to match up the chain length. So what you had to recognize was at the top of the tower, and if you did look on page 150 in your revision guide, there is a picture of the tower there. So the smallest chains moved to the top. So 3 to 4 carbons, LPG, that was at the top of the tower. Second one down was petrol. So this was 5 to 10 carbons in the chain. Then if we're going in size, we've got 10 to 16. So that's kerosene. That's the fuel used in aeroplanes. And then moving down the tower, diesel was next. So that would have 14 to 20. And then the biggest chains, 20 to 70 carbons, would be at the bottom of the fractionating column, which would be your fuel oil. So you're asked to write down these facts about viscosity. Viscosity is how thick or how runny a liquid is. So the thicker the substance, the higher its viscosity. So, for example, at the same temperature, honey is more viscous than water. Honey is thicker, slower, harder to run, harder to pour, okay? So thinking about viscosity, what effect do you think chain length has on viscosity? So the longer the chain at the bottom of the tower, the higher the viscosity. The longer the chain, the thicker it is. Okay? So the next slides give us a chance just to check our answers, make sure we understand it. So if we look at this is a picture, a very rough outline of the fractionating column. And inside the column, it is getting hotter towards the bottom of the tower. Okay? So the top of the tower is cooler and the bottom of the tower is hotter. Volatility increases going up the column. So the molecules at the very, very top of the column are more volatile than the ones at the bottom. Chain length increases going down the column. So at the bottom of the column, you've got the biggest chains. Flammability was linked to volatility. So flammability increases going up the column and boiling point increases going down the column. Okay. Why do the properties change? So it all really comes down to chain length. Stronger attractions mean more energy is needed. So longer chains have stronger attractions between the molecules. They have stronger intermolecular forces. And these stronger attractions need more energy to be able to break them. So that's why there's a higher boiling point. They can't evaporate because these forces are stronger between the different molecules. The higher boiling point means that it's less likely to vaporize at room temperature. So it's got low volatility. And that means lower flammability. Okay, so you are asked to write these down, these facts about the properties. And then we had some quiz questions. Now, this question had already been on, so I've explained this once. Which property of crude oil fractions allows them to be separated by distillation? So it's the fact that they are boiling and turning into a gas. So it's their boiling point. Ooh. On the next few slides, draw an arrow next to the column which matches the change in property. So some of us drew arrows and just got a little bit confused about what it was asking us exactly to do, which is one of the reasons I'm going over this. So increasing boiling point. So as you go down the tower, the bottom molecules have a higher boiling point. Okay. Viscosity. So the longer the chain, the more viscous it is. So as you go down the column, the molecules become more viscous or have higher viscosity. Okay, flammability. So the smaller molecules found it easier to overcome those forces and become a gas, and therefore were more volatile and then easier to set on fire. So flammability goes up the tower. Okay, and then on the next few slides, drag the pin to the fraction that matches the description. So which of these has the highest viscosity? Tar wasn't mentioned on the picture in your revision guide on page 150. But tar is a thick, black, sticky substance. It's put on roads to keep the gravel and stuff together. So tar has the highest viscosity. It's the most thick of these three liquids. Which of these would ignite easiest? So if you look at the fractionating tower, petrol was highest up out of these three, so that would ignite more easily. Which is used as a fuel in cars? So LPG is a gas, so that's not used in cars. Tar is too thick to pour into a car, so you should have chosen diesel. And then we ended with a 6-mark question, which was asking you to compare C3H8, which is propane, and decane, C10H22. And it gave you 3 things to write about. So you had to compare the 3 properties, which means you had to write about 3 different things. And then you had to kind of explain. So it does say, use the diagram to explain the differences. That means you've got to tell me why there is a difference. So point 1, propane is a smaller hydrocarbon, so it's going to have a lower boiling point compared to decane. It has a lower boiling point because it has weaker intermolecular forces to break. This takes less energy than a longer hydrocarbon. So it doesn't require as much heat energy to break the forces holding it together. Okay, point 2 is about viscosity. So propane is a smaller hydrocarbon. It will be less viscous than decane. Longer molecules get tangled up with each other, and this stops them from flowing. So that's what makes them thick and gloopy, the fact that the long molecules are tangled up a bit like spaghetti. And then the last point on flammability. Propane will be more flammable than decane because it is a shorter hydrocarbon. Longer hydrocarbons have strong intermolecular forces, and more energy is needed to move them apart. This makes them less volatile, so less likely to become a gas, and therefore less flammable. So, well done. Great work again today. Keep up the hard work. We're going to start setting you some portfolio work that we can use to prove the grade that you deserve at the end of the year. So make sure you're looking out for that, and make sure you are logging in every lesson to try every piece of work the best of your ability. And I will see you in the live lesson on Monday.